Hi guys, welcome to Smartherd. I'm Annapurna and this is the course on TypeScript. TypeScript has been gaining a lot of popularity lately and is also known as the superset of JavaScript. The TypeScript code is compiled to JavaScript and is sent to the browser for execution. We can also say that all the valid JavaScript code is a valid TypeScript code. We can use TypeScript for client-side browser application, server-side application, node application, and any other application which we can build using JavaScript. Yes, TypeScript has made coding in JavaScript easier, much more efficient, and faster. The goal of this course is to walk you through all the concepts of TypeScript. All the codes of this course is available on GitHub. You can go to this GitHub link and get all the codes. I have put the link of the repo in the description box as well. Also, please use the comment section below for any discussion or doubt that you have on TypeScript related to this course. It is a great place to clear your doubts and know the community that is learning TypeScript with you. By the end of this course, you will have a fully functional web app built with TypeScript. We will create a TypeScript application like this. I have named it Quick Math, where the user will enter his name and press this button to show number. Two random numbers will be displayed, and then using this random numbers, few basic maths problems are listed on hitting the Start Game button. You enter the answers, and the scores will be displayed on hitting this Calculate Score button. Depending on the number of the correct answers, this score is displayed. So we have created this entire app using HTML and TypeScript. To make the learning easy and convenient, I have divided this course into 6 chapters. In the first chapter, we will proceed with installing all the required tools and dependencies for TypeScript. I'll also show you everything step by step in detail. Next, we will see how to run the compiler from the command line itself. We will also check how to configure TypeScript with a new TypeScript configuration file. In the second chapter, we will cover the basic data types available in TypeScript. You will also see the advantage of type inference and type checking in TypeScript. Next, we will proceed with the third chapter, where we will check out the functions in TypeScript. We will include using types with the function, and we will also check out what are arrow functions. In the fourth chapter, we will create our own custom types using the classes and interfaces in TypeScript. This feature will help us to use the object-oriented techniques in TypeScript. In the fifth chapter, we will focus on the modules. Modules are the smaller, reusable chunk of code which we can use in different parts of our application and make it available for other pieces of code to use as well. We will also see how TypeScript finds out the module in the project and implements it. Next, in the sixth and the last chapter, we will see how to use the type declaration files. These type declaration files add to the strong typing support to any JavaScript libraries which we use in our project. And that's all. By the end of this course, you will be well versed with all the concepts of TypeScript, and you can start building your own TypeScript project, as well as you will be ready to use it with other frameworks like Angular. However, before you start learning TypeScript, you should be familiar with JavaScripts and the basics of the web processes. If not an expert, at least the basic. I hope you'll join me in this journey to learn TypeScript at Smartherd. See you at the course. I have put all the codes for TypeScript Fundamentals course in GitHub. You can just get into this link and find it here. Here is the Chrome extension that I'm using, outDir. This gives me the structured folder view for my project. For the codes, I have created separate branch for each chapter. You can just change the branch here and refer to the code for a particular chapter. For example here, chapter 2. Once you change the branch, you will get the codes for chapter 2. The code here in outDir also gets updated and you can clearly see the files. The main branch here has the final code for the demo that we completed in the last chapter for the course. You can also download the code from here. Either you can download zip or you can clone it using Git. So that's it. Anytime at any point in the course, if you find any difficulties with the code, you can just come here and check it out. Let's start with the first chapter. We will first set up TypeScript with all the required tools and dependencies and then run a basic TypeScript code. I will use the Visual Studio Editor. You can get it from the official website of Visual Studio, code.visualstudio.com. Download and install the suitable version for your system. Once the Visual Studio Editor is installed, it's now time to install Node and TypeScript. But before that, let's walk through the project folder that I have created. Here I have all the basic files required for our project. The first is the app folder. All the TypeScript code goes here. There is only one file in there now, named main.ts, which is currently empty. Next I have my CSS folder. This contains the CSS files from Bootstrap template I downloaded and a custom.css file where I have added few CSS tweaks. I have got a fav icon. Next I have the index.html file with the HTML for the app page. Let's have a look at this. I'll just zoom in this a little bit. This is a simple HTML file. I have referenced the CSS file here. This will add few styles to my page. Here at the bottom, I have added the script tag to reference the JavaScript files. This JavaScript files will be the output by the TypeScript compiler, which will add functionalities to our app. It has nothing for now. Also notice this div element with ID message. It will display a message on the screen. So this was index.html. Next we have package.json and packagelog.json file. This file stores information about the NPM packages we will use. You just need to paste this file in your project folder. We will come back to this in a while. Next we have the webpack.config.js file. I have manually created this file. This is for a simple development web server we will use to serve the app to the browser. So this basically are the files which we will start with. Now coming back to installing Node and TypeScript, we will use the terminal from the editor itself. Open the terminal and just check if you have Node installed already. The terminal opens up in my current directory. Now to check if you have Node installed, type npm-v. Hit enter and I got the version 8.5.0. If this doesn't give you the version, you need to install Node in your system. To install Node, just go to nodejs.org and download the right package for your system and install it. From here, you will get both Node and NPM in your machine. Node and NPM are practically required for modern web development, so it is a good time to get it. Alright, half of our installation task is done. Next we need TypeScript. To install TypeScript, there are many ways. To get started, you can just go to the official website typescriptlang.org. Go to the download tab. Here there are several ways mentioned to install TypeScript. Using NPM, using Visual Studio. A little down the page, here is the option to globally install TypeScript. We will use this. Install TypeScript globally in the machine using the -g flag with NPM. This will help us to use TypeScript from anywhere on our computer. Just copy this and paste it in the terminal in your Visual Studio. Hit enter. This only takes a couple of seconds to run and you can see that TypeScript is installed. I had already installed TypeScript in my machine and you can check the version using tsc-v. My version is 4.6.2. As the version keeps updating, this may vary for you. So we are done with installing Node and TypeScript. Now we need all the dependencies that we need to run our TypeScript project. I had mentioned that I have all the dependencies added in this package.json file. I'll reduce the window for terminal now. And here you can see in my package.json file, I have got this list of dev dependencies for our demo. We will run a few commands that will install these packages in our project folder. The TS loader converts TypeScript to JavaScript. The Webpack serves the app to the browser. It is a bundler tool which bundles our JavaScript application and creates static assets from which the content is served. We will configure this as a developer dependency. This will provide live reloading, and instead of creating the bundled files in the dedicated dist folder, it will be created in the memory. You will see what I mean by this later in this course. I'll start the web server using an npm script. I have named the script start and it will just run the command webpack serve. Before I run the app, I need to use npm to actually install these packages which I have referenced in this file. You'll need to do this too if you plan to follow along using the project in the GitHub repo I had mentioned earlier. So in the terminal, I'll clear this first. And I just need to type npm install in the terminal from the main project directory. This will install all the packages that we need to run the app. Notice here we have the node modules folder created. All the packages are installed and here they are. So we are now done with the node packages. Now is the time to create tsconfig.json file. This is a TypeScript configuration file which we will look in detail. To create this file, we just need to type a terminal command. tsc-init. Hit enter and here you can see I have got this tsconfig.json file created. Here it has shown me the list of options which has been added to my configuration file. When I go to this file, and here you can see all the options that are available for configuration in the TypeScript. These are a list of compiler options, most of which are commented out. We can uncomment the option which we need to use. Let this file be as it is for now. It is a special TypeScript configuration file we will discuss in the upcoming lessons. However, we don't need few of the options which are enabled here. The first one is this module option. I'll just comment it for now. We will come back to this later. I'll also comment the strict option which has been enabled. Next, I need the sourceMap option. So I'll just find it. I'll uncomment this. When I enable this option, this will create sourceMap file for the JavaScript files. So this will be the TypeScript configuration we will start with. So now we have all the TypeScript setup we need for our project. It's now time to start writing the code in TypeScript. We will start with the main.ts file in our app directory. TS is the extension we use for the TypeScript files. We will begin with a simple code snippet with a function name startGame. In this startGame function, here I have fetched the reference to the div element I mentioned earlier. Its ID is message, and then I have set its inner text property as this string. Welcome, starting a new game. This is just a plain old JavaScript code. A valid JavaScript code is a valid TypeScript code. This function will be called when the Start Game button is clicked. So let's attach a listener to the button and call this function. And here it is. The ID of the button is Start Game, and here we have added a click listener. Now let's run the code in the TypeScript compiler. The purpose is to verify if the TypeScript setup is working fine. To do that, I'll open the terminal. And here in the terminal, since our code is in the app directory, we will move to the app directory and then compile the code. To compile the code, we will use the command tsc followed by the file name main.ts. Hit enter. And the compiler ran with no errors. Now here in the project you can see we have got a new file created, main.js. Now when I open both these files side by side, you can see both my TypeScript and JavaScript files are identical. The JavaScript output by the compiler is readable as well. To make the app functional with the JavaScript file, we will have to include it in the index.html file. I'll close this here. And in my index.html file, I'll add the reference to the JavaScript file here in the script tag, main.js. It is in my app directory. So now we have linked our JavaScript file to our index.html page as well. And now we'll start the web server. In the terminal, we will use the npm script that we have added in the package.json file. So from the root directory of our demo app, npm start. Hit enter. I'll increase the terminal window. And here you can see our web server has started and all our node modules are being compiled. It is running locally on port 8080. Now I'll go to this URL, hit command and click. And this opens up in the browser. This is the index page of my app. We got this interface from index.html file, and right now only this button is functional. I'll open the console, and on hitting the Start Game button, I'm getting the message, Welcome, starting a new game. So it's working as expected. Now as we proceed further, we will turn this to a fully functional mathematical app which we saw in the introduction. Now that TypeScript is installed and is working, let us move to configuring a TypeScript project file. It's time to get back to the tsconfig.json file which we had created while setting up the project. Now the tsconfig file is just a regular JSON text file. This file also has content in form of key value pairs just like any other JSON file. This stores information about how our project should be compiled, so we don't have to add the compiler option again and again while we run a compiler. We can specify the list of files to be included or excluded in this file while we compile a project. Best of all, the TypeScript project files support configuration inheritance. This means in a large project, we can create a tsconfig file at the root of the project like here, which will hold the default configuration options we want to apply to our project, whereas we can have a separate TypeScript project file in different folders in the project. For example, if we have one here in the app folder. This will selectively override or add to the options in the root project file. We will see how to set such kind of configuration inheritance in a few minutes. Let me show you a list of compiler options available to us from the TypeScript official webpage. In the Docs tab, if you move down to the project configuration section, TSC CLI option. In this link, you can find the alphabetical list of all available options. Here you can see we have a help option which gives us local information for help on the CLI. Let's move to VS Code and see this in action. In the terminal, when I type tsc-h and hit enter, it gives me the list of all available compiler options. So this was about the compiler options. Coming back to our tsconfig file, we had created this file using the command tsc-init. If you want, you can remove this entire code and write the only options which you need. But we will stick to use this file by commenting out the options which we don't need and uncomment the options which we need. We had made a few updates in the first lesson. We will do some more now. The first we will see is this target option. This specifies the version of JavaScript which will be output by the TypeScript compiler. ES 2016 is widely supported by all browsers, so we will leave it as it is. Next, this compiler option module was commented out in the earlier lesson. Going further down, here we have the sourceMap option. SourceMap was enabled in the earlier lesson. Then next I'll uncomment this out directory option. This specifies the output directory in which the compiler should save the compiled JavaScript file. I'll set it to a folder named JS. It doesn't exist yet, but you will see how the compiler creates this for us. Next, I'll uncomment this strict option. The strict option enables all strict type checking options, and this is helpful in pointing out the potential errors in our code. You'll see the effect of this soon. We have another compiler option here, esModuleInterop. This is related to modules and I'll turn it off for now. And at the end of this, I'll add the watch option. This leaves the compiler running so that it can automatically recompile the source files as they are saved. This saves a lot of time during development. Add a comma here after the previous option. And we are good with the watch option. This curly braces marks the end of the compiler options object. There are other things which we can specify inside this config file. That was it for the config.json file for now. Since we have the out directory as the JS folder, we no longer need the main.js file which was created earlier. So I'll delete it for now. And now from the terminal, I'll compile our project. Now after the settings that we have done, we don't have to run the compiler from the directory which contains the tsconfig file. The compiler will look for the file in the current directory. If it doesn't find one, it will move up to the directory hierarchy looking for one. So we are here in the Quick Math app and not in the app directory. We are using the configuration file now, so just type tsc and hit enter. Now the compiler is running on the watch mode, obeying the configuration option we had set. And here we have got an error when we turned the strict option to true. Here it says the object is possibly null. If they are null at the runtime, our app can blow up in the browser. For this demo, we know that the messages element and the start game elements does exist in the HTML. I'll quickly resolve this by adding a non-null operator here. And I'll speak more about the strict option later in this course. So as I added the operator, the code got recompiled and you can see the error disappears in the terminal. We also have a JS folder created here for the JS output file and the sourceMap file. To use this newly compiled JS file, we need to update the script tag in the index.html file. I'll minimize this terminal and in the index.html file, I'll update this location to use my main.js file in the JS directory. We will start the server, add a new terminal, npm start, command click, And now we have got the updated files here in the browser. In the Chrome Developer Tools, in the Sources tab, you can see here is my main.js file. And here is the main.ts file. Now in this main.ts file, when I add a breakpoint here on line number 4 and hit the start game button, you can see the browser is executing the JavaScript file. And I have added the breakpoint in the TypeScript file. When I hit the start game button, the debugger stopped at this breakpoint. So you can use the Chrome debugger tools as well to inspect the code. Click the continue button and allow the code to finish running. So we have a working project configuration file and we are able to debug our code in the browser. Next we will see how we can use multiple configuration files to control more precisely how our files in particular directory are compiled. After checking out the tsconfig file in the project root directory, now let us see how the configuration files in the different directories of the project can inherit the settings from the root config file. It is basically helpful in large projects where different sections require different settings. For our demo app, this configuration file, which we have created, will be the base configuration file, the one which remains in the root directory of the project. So first I'll rename this to tsconfig.base.json. Once this is done, I'll manually create the new configuration file in the app directory which will inherit the settings from the base file. I'll name it tsconfig.json. I'll add the opening and closing curly braces that must surround the options. Now press Ctrl space in Visual Studio Code to see the list of settings which we can specify. The first one I need to use here is the extend setting. It specifies which config file this one extends. Here I'll mention our base file. So the value I'll give here is /tsconfig.base. The JSON file extension is not required here. Now this config file will use all of the options in the base configuration file plus any additional options that we add here. Now here, let's add some compiler options. Here I have added the compiler options section and added the option remove comments and set it to true. This will just give us a simple change by removing the comments so that we can make sure that it is using both the config files correctly. I'll add another option here, include. Here I have used a glob to specify which files should be compiled. Here the dot begins to look in the current directory. 2 asterisks will tell it to search recursively through all the subdirectories, while this asterisk will look for all the files with valid TypeScript file extension. So now in the terminal, we will move to the app directory that contains the inherited config file and we will type tsc and start the compiler. It is running in the watch mode, which we had specified in our base configuration file. So this implies that our base file is correctly found. Here is the comment that I had mentioned in the main.ts file, which is currently not found in the JS file. Hence, our compiler option from our inherited config file is also being executed. Inherited configuration files are of not much use in small projects like us. However, you should know how it works to work on the large project. Now let us configure Webpack to run the compiler so that we don't have to start it again and again with the tsc command in the terminal. In this lesson, we will see the Webpack configurations that we will use for all the upcoming chapters in this course. Moving to the editor, we will use these configurations to start the TypeScript compiler. I'll close the terminal for now. Let us understand these configurations which we have in our webpack.config.js file. Here, the entry option is where the Webpack looks to start building the bundle. The DevTool option tells Webpack that source maps should be created in line with the final bundle that it produces. Providing the mode configuration option tells Webpack how to use its built-in optimization accordingly. Its value can be development, production, or none. Next is the module option, which configures the TS loader to run the TypeScript compiler for us. It generates the JavaScript output that is added to the final bundle and sent to the browser. The resolve property here tells Webpack which files it should use for module resolution. Output specifies the name of the bundle file Webpack will produce. This is the name of the file that will be sent to the browser, bundle.js for us. The last section here is the configuration to use Webpack with the development server to provide live reloading. So running the npm start will invoke the Webpack with its configuration file. TS loader will compile the TypeScript. Webpack will bundle the output JavaScript and start the development server. And the browser will now use bundle.js file generated using Webpack. So now I no longer need this JS folder and the files in here. So I'll delete them. And then in my index.html file, I'll update the script reference to bundle.js. Now by default, the Webpack dev server won't actually write a file to the disk named bundle.js. It will be created in the memory and served to the browser. So we won't see it show up as a new file in the project. Let's see this in action. In the terminal, here I have my server running. Moving to the browser, I have opened my network tab in the developers tool here. And now when I refresh this page, you can see bundle.js is loaded here. On hitting the Start Game button, I get the message that was expected. Now we will use this way to compile the code and serve it to the browser. So this was all about our first chapter on setting up TypeScript and configuring the project. Summarizing what we just learned in this chapter, we installed all the dependencies, npm, TypeScript, Webpack, and other modules. We compiled the TypeScript file from the terminal. We also configured the TypeScript configuration file tsconfig.json, the default one at the root, as well as the inherited one. Then we checked how we can use Webpack built-in development server to compile our TypeScript code. Let us now jump to our next chapter and see the built-in types in TypeScript, how they make the coding efficient and help in checking errors. See you there. Using TypeScript built-in types. Let us now experiment with some TypeScript syntax and the built-in data types. We will check out some of the primitive data types available in TypeScript. I'll also show you how to use let and const keyword, which we can use in TypeScript as opposed to using var in JavaScript. We will declare the variable using TypeScript type annotation and see how type inference work with the Visual Studio Code editor and TypeScript. Null and Undefined have created a lot of unforeseen bugs and errors in JavaScript. We will see how to manage this in TypeScript. We will wrap up this chapter with a look at how TypeScript allows the control flow based type analysis. Now, let us start with the basic types in TypeScript. TypeScript supports all the primitive data type available in JavaScript. It also adds a few new types to the list. Let's see what are they. TypeScript has Boolean type. These are simple true and false values. Next, we have number data type, which represents the number and floating point values, just like JavaScript. There is string data type, which supports basic text data. Same as in JavaScript, the string literals are surrounded either by single quote or double quote. TypeScript also supports the string templates, which are surrounded by the backtick character. We will see its use in the demo. TypeScript also has arrays, which again comes from the JavaScript. These are the ordered list of data. A new type which TypeScript supports is enum. Using enumeration, we can give names to a finite set of numeric values so that it becomes easy to use in our code. We will use most of these types in our demo. Few more data types that TypeScript supports are void. As the name suggests, it represents the absence of a type. We will mostly see this with functions that do not return any value. Null and undefined. This represents the absence of a value or an uninitialized value. Unlike JavaScript, we cannot assign null or undefined to a variables of other type. For example, we cannot assign a null value to a string type variable. Declaring a variable with null or undefined type allow us to assign the null or undefined values selectively only to those variables. Next, we have any type. Declaring a variable as any type lets us assign any value to a variable. This means it lets us opt out of the type checking by the compiler. This can be helpful while using a third-party JavaScript library where we are not sure of the type back from a library function. Now let us see how to declare variables in TypeScript. JavaScript has allowed the usage of a variable even before declaring it, like this. Here I have logged the variable first and then assigned the value to it. This gives no error in JavaScript. This is valid because of JavaScript hoisting at runtime. Hoisting means JavaScript effectively moves all variable declarations to the top of the code block in which they are declared. However, this will generate a TypeScript compiler error. Hadn't we said that a valid JavaScript code is a valid TypeScript code? Well, not in this case. Here, the TypeScript compiler will generate the error even before it reaches the JavaScript engine to run the code. Let me show you this in the editor how it works for TypeScript. So here I am continuing with the app which we had created in our previous chapter. Let's see the demo in the main.ts file itself. When I use the same code that we had seen in the slide that was used for JavaScript, here I immediately get an error. It says variable myString is used before being assigned. So this does not work in TypeScript. However, we can use var to declare the variable and then use it. So if I move this console statement after the variable declaration, this works totally fine for me. We can similarly declare a variable using let in the same way as we have used var. So here I'm using let to declare the variable myString2. Declaring constants also work the same way. We need to use const keyword instead of let. Now here myString3 has the value hello world and it is declared using const keyword. If I try to reassign this variable with some other value, I'll get an error. Here you can see cannot assign to myString3 because it is constant. I'll just remove this. Now the basic difference between var, let and const is that with var, the variables are globally scoped or function scoped. That is, if it is declared inside a function, it is available only within the function. If outside a function, they are global variables. Whereas variables with let and const are block scoped. The block may be a if block, try catch block, for block or any code block. It can be used only in the block where they are declared. With var and let, we can declare a variable even without initializing it. However, with const, we need to initialize the variable when we declare it. the value of the variable can be changed when declared with var and let, whereas it should never change when declared with const. We will mostly use let and const in the demo in this course. Since these are block scoped, it becomes easy to track the variables, debug and prevent the errors. Let us now have a look at type annotations and type inference in TypeScript. Type annotations specify the type of value that can be assigned to a variable. It is basically using data types. Before starting, I am going to comment out the strict compiler option here in our tsconfig.base.json file. This way, the compiler will be a little more permissive while we work through this demo. Done with this file? Now in the main.ts file, in the start game function, let me declare a new string variable, say player name. Now I have annotated it with a string type. We annotate a variable by adding a colon just after the variable, followed by the data type. Now since I have declared this variable as a string, I can assign only string value to it. Now if I try to assign a numeric value, say 5, you can see I get a compiler error. It says type number is not assignable to type string. So when a variable is annotated with a particular type, only that type of value can be assigned to the variable. We can also declare variables without adding type annotation to it. Now let's say if I declare a new variable age and assign a number to it. Notice that I haven't added type to the variable age. But if I try to reassign a string to this age variable, I get an error again. It says type string is not assignable to type number. Here, TypeScript has inferred that the type of this age variable is number. This property of TypeScript is called type inference. Also, if I try to assign the null value to this age variable, I do not get an error. Now mark this difference while we have turned off the strict type option in our tsconfig.base.json file. We'll see the difference what it makes further in this chapter. For now, I'll keep it as it was. So the thing to note here is, the type annotation is not required while defining a variable in TypeScript. However, I recommend using it as a good practice. This will avoid confusion and will be helpful for other developers working for you. I'll remove this extra codes for now and also this ones from my previous lesson. Now in cases where we have the value assigned to the variable, it is easy to infer the type of the data it will hold. Now what if a variable stores a value that comes from a function? Let's say I have another function here, welcome player. This function returns a string value, hello player. I have hard-coded this value for now. And now here in the start game function, I'll create a variable welcome message and assign the return value that I get from the welcome player function. Looking just at this variable, it is not immediately obvious what type of data will be returned from the welcome player function. However, if we hover over this variable welcome message, we can see the type of this variable is string. Again, the type inference by TypeScript. Now if I change this return value of the welcome player function to let's say 5, here the type of this welcome message variable becomes number. So this shows the TypeScript compiler makes our task a lot easy and thus is great at pointing out potential errors in the code when it sees us returning the types incorrectly. I'll change this return value to what it was. And now let us see how to use the template strings also called the template literals, here in our demo. For using this, I'll modify our code a little bit. I'll update the welcome player function to accept a parameter, say name. Next, I'll create a variable player name and pass it to the welcome player function. And now I'll use this welcome message variable. I'll display it in the message element. So now I'll remove this hard-coded string and use welcome message. Next, in the welcome player function, I'll change this return value to use the string literal with the backtick character. Just notice this is not a single quote. Here is the dollar sign followed by the variable surrounded by the curly braces. We can put in an expression here as well. Here, instead of this name, the value of the name will be inserted here. So here we have a player name which I am passing to the welcome player function. The welcome player function takes the name, creates a string and returns its value to the welcome message variable, and I have displayed this welcome message variable in the message element in our index.html file. Now I'll build this project and run it to make sure that it still works fine in my browser. I'll do this all in the terminal itself. I have got no errors here and the compiler is now watching for the changes. Now that it is running, let us move to the browser. And here I have my game loaded. I'll refresh the page, start the game, and here it gives me the message. Hello Ananya, let's start a new game. So about type inference and type annotations, TypeScript is a typed language. Unlike JavaScript, we can define the type of the value a variable can store. It is not mandatory to annotate the type. However, I recommend you to follow the practice of doing it. The TypeScript compiler infers the type of the variable when there is no explicit information. The variables can be declared with var, let or const keyword. However, using let is recommended. We will use const when we want the value of the variable to be constant and not change. TypeScript also supports string literals, which we can use to build strings based on the variable's value. Remember, I had mentioned in the previous lesson about the null data type. But before using that, we need to know about the union types. So let's first see what are union types in TypeScript. Defining union types in TypeScript. Union types are a way of defining several types that can be assigned to a variable. Now let's see how can we do that. Here is the syntax. Let var followed by colon and then the types. Each type has to be separated by the vertical bar character. For example, here in this value, we can assign a string type value or number type value. Let's see this in action in our editor. So here I am with the code from my previous lesson. Let's see how the union types work. Now here in this editor, I'll use this player variable to demonstrate the union types. Let's say I'll change this player name types to have a string type or the number type values. So here I have defined my union type variable and have assigned a string value to it. Now when I try to change the player name to have a number value, the compiler doesn't complain. However, if I assign a boolean value to it, say true, I get an error. It says boolean type is not assignable to type string or number. So the acceptable values are limited to the types mentioned in the union. I'll remove this for now. Now there might be case where, depending on the type of values that a variable has, we might want to perform different operations with it. One of TypeScript compiler's property is control flow based analysis. Here, the conditional behavior of our code is taken into consideration. I have the player name variable to be union of number and string type here. Now let me just add a block of code to show the control flow based analysis performed by the compiler. Now here I have this code. Here I'm using the typeOf operator to find the type of the variable. I have written the variable player name here. Now I'm just using this code to show you how the flow works. It's not important what we do with the variable at this moment. When I hover over the player name, it doesn't show me the union type here. It just shows me the type to be of number. When I comment this out, now the player name has the string value, and when I hover over it, the type inference gives me the type of the player name as string. Moving inside the if block, here the player name is string, whereas here in the else block, the player name is never. Never means this variable is never used. If I uncomment this and check it here, it is of number type. Hence, the type of this variable in the if block is never, whereas in the else block, the player name of number type is used. The compiler has narrowed down this variable down to the most specific types. However, outside the block, here where I have defined it, it is still the union type, string or number. I don't need all this code, so I'll just remove it and change this variable declaration to what it was. So in JavaScript, we can assign the null and undefined values to any variable, but it is otherwise in TypeScript. Null and undefined values causes a lot of bugs. In TypeScript, if we want a variable to have the null or undefined type as a value, we use strictNullChecks compiler option. Let us check it out now. Null and undefined values causes a lot of bugs. In TypeScript, we use strictNullChecks compiler option to prevent a variable from having null or undefined values. Let's check it out how this compiler option can be helpful to resolve a lot of bugs due to null and undefined values. When this compiler option is set to true, a variable cannot use null or undefined as the valid values. And also if we want a variable to have the null values, we need to explicitly define the types in variable declaration. In my main.ts file, I had shown you when I assign a null value to this player name, I don't get an error as of now. Undefined works as well. When I remove this assignments and just leave the player name declared without any value, notice I'm passing this player name variable to the welcome player function itself. This might be null and might cause an error in the runtime or give us some weird output in the browser. This is not acceptable. Let us take advantage of TypeScript and see how to take care of this. First, I'll go to tsconfig file and uncomment this strictNullCheck option and leave it as true. After this, to be able to use the null or undefined values, we need to explicitly define these types in the union type. Now the compiler has been running in the watch mode. So here in the main.ts file, I immediately get an error. It says the variable player name is used even before being assigned. Well, this is helpful. When I assign a string value here, the error is gone. However, if I reassign the null value to this player name, I have an error here. It says type null is not assignable to type string. You can see null itself is a data type in TypeScript. Similarly with undefined, it says type undefined is not assignable to type string. The compiler option is named strictNullChecks, but it really applies to the null and undefined types. Now let's say for some reason I want the player name to be undefined. So here, if I add union type as undefined, I can now assign the undefined value to it and the compiler accepts it. However, I'm getting the error here for null. Null has its own distinct type in TypeScript. If I add the null type here in the union, this null value is acceptable now. This way, the strict null checks prevent the errors that can be caused due to the null and the undefined values in TypeScript. It can help to eliminate a lot of runtime errors. We can, however, easily opt the null and undefined types with a union type. We have the flexibility. We don't need the undefined and null for this variable, so we will remove all this and give it a regular string value. Now let us see what is any type in TypeScript and details about type assertion. Sometimes few third-party libraries uses dynamic types or may have an object literal which doesn't have a specific type. In such cases, we use type assertion to get the correct type. The syntax for asserting a type is to place the type inside the angle brackets in front of the variable. Here I'm using number type and any value is my variable. Or alternatively, we can use the as keyword after the variable and specify the type that it should be. Here any value again the variable and number is the type. Let's see this type assertion in action now. I'll demonstrate this at the end of this file. Now let me define a variable with any type. Defining a variable with any type means we can assign value of any type to the variable. It might be string, number or boolean. Here I have initialized it as a number type. Now when I try to assign a string value to it, the compiler doesn't give me any error. Now let me define another variable here, let's say final string which is of string type, and assign it a value. This toFixed function returns a string which I have assigned to this final string variable. Now I can assert the value of this anyValue variable to be of number type. To do that, I'll enclose it within a parenthesis and assert the type to be of number inside the angle brackets. So this is type assertion in TypeScript. I'll remove this for now. And here we have our type asserted anyValue variable assigned to the string final string. Now we can also use the type assertion using the as keyword. Let's say I'll change it to final string 2 and here any value as number. This both does the same thing, but you can choose the syntax whichever is convenient to you. So this was all about using the any type and using type assertion in TypeScript. This was just for the demonstration purpose, so I'll remove it. So in this module, we covered several built-in TypeScript types and their features. We saw how the let and const keywords make sure we define a variable before using it. We saw that const assures the value of a variable doesn't change. Type annotation feature of TypeScript increases the clarity about the type of variables. The control flow based analysis helps us to have conditional behavior for our code and work with specific types. We, however, have the flexibility to use several types for a particular variable using union types. TypeScript prevents unintended bugs, especially in case of the null and the undefined values. It provides strict null checks, thereby eliminating the chances of unforeseen bugs and weird consequences. Whereas TypeScript assertion can give the compiler specific information about the variables. And all in all, TypeScript has made the development process efficient and handling the bugs easier. So this was all about using types in TypeScript. Let us now move further a step ahead and use this type annotations and assertion property to write better functions and use them efficiently in TypeScript. Using functions efficiently. Functions are the building blocks of TypeScript as well as JavaScript. In this chapter, we will learn about functions in TypeScript in detail. We will start with adding annotations to the functions. The purpose of using annotations in function is same as using it with the variables. This makes the function easy to use. We will then learn arrow functions in TypeScript. It is an alternative syntax to define functions, mostly the anonymous functions. In TypeScript, function itself has a type which we can define in the function signature. We will see how this works in this chapter. So let's start with our first lesson to add type annotations to functions. Functions are an integral part of modern coding language. Let's have a look how they work in TypeScript and how they are different from the TypeScript's parent language, JavaScript. Here I am at the end of my main.ts file. I have added two functions here for demonstration, demo function 1 and demo function 2. Let's start with demo function 1. Here is a plain old JavaScript function. Looking at this function, it is hard to tell how to use it. It takes two parameters, but what kind? Not mentioned. In such cases, TypeScript explicitly gives any type to these two parameters. You can check out the tooltip here. This means that any values can be passed to the function and will get no type checking support from the compiler. Looking at the function, we can't even tell what value it returns. Let's say if we return a boolean here. To know this, we will have to go through the entire function code. This is not a good practice of writing code. This function in TypeScript can be better written like this. To the same function, I have just added a different name to avoid error in the editor. I have added the annotations here for the parameter. The syntax is same as we have used with the variable. The parameter followed by colon and then the type. This way we can annotate the types for our parameters. And this annotation here specifies the return type. Add a colon after the closing parenthesis, after the parameters, and then the type of the value which the function will return. Let's see more about functions. I'll remove these functions from the demo file. And continuing with the function that we already have here, we will see welcome player. This takes one parameter, name, and it returns a string. But there is no type annotation here. When I hover over this name parameter, I have any type assigned to it. Using any type implicitly or explicitly turns off the type checking for a variable or parameter. We need to avoid this. To avoid even accidentally using an implicit any type, we can use the noImplicitAny compiler option that TypeScript provides. For that, we will open our tsconfig file in the root of our project directory. And here we have noImplicitAny option. This option prevents the implicit any type annotation. We can, however, annotate any type to a variable explicitly. This option here is commented out. Let's uncomment this. Now, wherever there is implicit any type annotation, we will get the warning. Let me show you how it affects our code. Here we have an immediate error for this parameter of the welcome player function. Our compiler is running and hence this compiler option has put into effect. Now this will be a quick fix. We know the parameter here will be string, so I'll just add a colon after the parameter and then the string type to annotate the parameter. The compiler is now happy. We will also add the return type for this function. It returns a string, so I'll accordingly add a return type here. After the closing parenthesis, add a colon and then string annotation. I encourage you to use this noImplicitAny option to improve your code. It will be helpful to remind about the missing type annotations on function parameters which might cause a bug. Now let us see more of functions and parameters in TypeScript. In this lesson, we will check out optional parameters and default parameters in TypeScript. Before I start, I have made some updates in the code. Let me walk you through it first. In my index.html file, here I have an input box for the user to enter the player name. I have put its ID as player name. We will use this to fetch the name of the player. Going down in the file, I have added this ID player score in the small tag here. We will use this ID to reference the scoreboard and display the score. So this was all the changes I have made in the index.html file. And then in the main.ts file, I'll just close this window. I have added a simple function display score here. It takes two parameters, score which is of number type and player name which is of string type. This function doesn't return anything, hence the return type is void. Here I have fetched the HTML element which displays the score and has ID player score. And then I have added the string as the inner text of this HTML score element. Let me just quickly add the comments for this function. Now coming back to our start game function, here I have the player name string. To begin with, I have assigned a default value to the player name. And now when I call the display score function, I'll pass two parameters to it, one for the score and other for the player name. Let's say 10 and then this player name variable. The compiler is happy up to this point. Let us run our file and make sure we are good to go. Our web server is already running. And now I'll just reload this page in the browser. And now when I hit start game, here it gives me the updated output, player name and then my score with 10. So it's working as expected. I'll minimize the terminal. If I again call this function display score, and now if I just pass the score to it, I get an error. It says expected 2 arguments but got 1. That is because in TypeScript all the parameters are required unless otherwise mentioned. This means we can mark a parameter to be optional in a function declaration. So in my display score function, if I add a question mark after this player name parameter, it will flag this player name parameter as optional. However, it is important to note that all the optional parameters must appear after all the required parameters in the function signature. Now when I have made this player name optional here in the display score function, the error here is gone. And now I can call the function even with a single parameter, which is my score. So this way we can use optional parameters in TypeScript. Speaking of the default parameters now, I will use this display score only to show you the default parameters. Now let's say in this function itself, the player name parameter is of string type. I'll remove this question mark and assign a default string, say math player, to the player name using an equal to sign. This effectively makes the player name optional and assigns a default value to it, even if we don't pass any value for this player name. So now we will stick with calling the display score function with just one parameter, and I'll comment this one out. And now when I move to the browser, refresh the page, and when I hit start game, the player name here gives me math player. This means our default parameter is working. Now, however, for the default parameters, if I pass a value for the player name here, I'll get the passed value instead of the default one. Both are valid. Let's say I'll pass a hard-coded string, John. Moving to the browser, I'll hit start game, and here I get John, your score is 10. So this was all about default parameters. Now let us use all this that we have learned and take our demo app to the next step. Here we already have the display score function to output the score in the scoreboard. I'll define another function to fetch the input from the user. And here it is. This getInputValue function accepts the ID of an input box element. I've annotated it as string type. Here I have fetched the element by its ID. I'm passing the IDs of actual input elements in the demo here. So I have added a type assertion here that will treat the element which was found from this as more specific HTML input element type. I have assigned it to the input element variable. Here I am bringing out the value of the element. If the value is an empty string, it returns undefined, else it returns the string value entered by the player. Hence, the return type annotation is the union of string and undefined. Now moving back to the start game function, I will now remove this hard-coded username assignment, and I'll fetch the player name using the getInputVal function and pass the ID of the input element. ID is player name. We had seen it in the index.html file when we started this chapter. Now here I'm getting an error. The type of player name is string or undefined. So I'll have to make it union here as well. I'll now remove the code to display this message. We don't need it anymore. I'll also remove the welcome player function. Not required. And now when I call this display score function, I'll pass the player name parameter which I get as the user input. I'll remove this and we'll just keep it player name. In the function display score, I'll keep the default parameter value for the player name as math player. Our code is now clean. And now let us run the app to check if we are in a good place here. Moving to the browser, refresh the page, and now I'll hit the start game function without entering the player name. Math player, your score is 10, and when I enter the name here, say Annapurna, and start game, my name updates. Now here in the display score function, if I remove this default value for the player name and just mark it as optional, this is going to work. For the moment, I'll remove this parameter here, and now when I run the application, on hitting start game, it gives me undefined in the output. I don't want to see this in the browser. So I'll just keep it as it was with the default parameter value math player, and we are good to go. Moving ahead, we will look arrow functions in TypeScript. Arrow functions in TypeScript are a little tricky, so we will first understand this and then implement it in our demo. Arrow functions are basically anonymous functions, also called lambdas in other programming languages. These anonymous functions have a very simple syntax. It might look a bit tricky in the beginning, but here it is. We use such anonymous functions to pass it as arguments to other functions. The general syntax of an arrow function is the parameter on the left, followed by an arrow. This arrow is made up of equal to sign with the greater than symbol. Okay, so the arrow is followed by the function body. Parameters, arrow, and then the function body. Let me show you a few examples. This is a single line arrow function. Here I have declared a variable, named it doubleIt. This is the parameter with the type annotation inside the parenthesis. You can add as many parameters as you want. This works like normal function parameters. Then there is this entire function on the right side of the arrow. I have just used the parameter x and multiplied it by 2. This is a very basic example of arrow function with a single line of code. The arrow functions like this with single line of body have implicit return statement. The result of x multiplied by 2 will be returned from the arrow function. And we can now call this function by using the name of the variable to which the function is assigned, followed by a pair of parentheses and a parameter. Here, the number type. Now checking out a little more complex example. In case of multiple line arrow function, we use the curly braces. And here, we also have multiple parameters. Inside the body of the function, I have defined another variable z here, and then added an explicit return statement in which I have added the 3 variables like this. And then in the same way, call the function using the variable to which the function is assigned with 2 parameters. So this way we can define the arrow functions with single line body, with multiple line body, with single parameter or multiple parameters. Now there are cases when we declare a function with no parameter. In such cases, just add empty parentheses like normal functions without parameter. And to use this arrow function, we will just call the function with empty parentheses. So this was about arrow function. Now that you have got a basic idea about the arrow functions, let us see the code in action in the editor. Let's convert a traditional function to arrow function. Here in my main.ts file, at the end of the file I have added a simple function named logMessage. It takes a string parameter and returns nothing, hence the return type void. This has a log statement which just simply logs the string parameter. Now we will convert this function to an arrow function. Arrow function, as we know, are anonymous and do not use the keyword function. So I'll remove this function keyword from here. And instead of using this log message as the function name, I'll define it as the variable. Now for the arrow function, we need to add the arrow. So after this return type void, I'll add the arrow here. Type annotation are normally not used with arrow functions. So we can also remove this return type from here. Now since this is a single line of code, to make it simpler, we can also remove this curly braces and move this line of code into the single line. So now we successfully converted a traditional function to an arrow function. This is just a demo to use arrow function. Generally, the traditional functions are much more convenient to read and use in most of the cases. However, the arrow functions are mostly used when we need to pass an anonymous function to another function. This happens a lot in TypeScript and JavaScript codes. So now let me call this arrow function using the variable logMessage and pass a string to it. So I have called the logMessage function and passed this parameter to it. Moving to the browser, opening the Chome Developer Tool. In the console, we have got our log message. Welcome to test your math. So this was all about arrow functions. Now like we have defined this function here, we can even use it as a type. Let us see how. Function types in TypeScript. In this lesson, we will see how TypeScript functions have their own type and how we can use it. The type of the function is defined by the type of all the function parameters and the function's return type. Let us see how. So here we have the arrow function and here we have used it. So first let me delete this call to the log message function, and I'll now add another arrow function to log the error. I'll just copy this and paste it here, and I'll name this log error, and here console.error. This accepts one string parameter and just logs a message in the console error. So both these arrow functions are identical, as you can see. On hovering over this, the pop-up shows me the function type. It takes a string parameter and returns void. Similarly with this function, it takes a string parameter and returns void. This is what we are calling as the function type. This means if we declare a variable to have the same function type, we can assign any function of this type which takes the string parameter and returns void to the variable. Let's try it out. So here in my display_score function, I'll declare a new variable logger and assign it the function type annotation that we just saw. To give the logger variable the function type, we will add a colon, just like any other variable, and then add the function parameter with its type, followed by arrow and then the return type. So here we have a variable with a function type which accepts one string parameter and returns void. In our code, we can assign either of these two functions to the logger. Now to use it, I'll just add a if block here. So what I'm doing here is I'm checking if the score which we have received as the function parameter is less than 0. If it is less than 0, this logger will be assigned the log error function, else it will log the message. Now I'll just use this logger variable to call the assigned function, whatever it is. Here is the string parameter I have passed to the function. Now we are ready to use the logger variable. In the start game function, to check both the condition, I'll call display_score 2 times. The first call is display_score and I've passed the score value 10 and then the player name. I'll call it second time and pass the score value -10, which is less than 0. Let us run this and check in the browser. Now when I hit the start game button, in the console, the first call with score 10 logs score 10, and in the second call with score -10, it is logged as error. And we did this using the function types in TypeScript. Awesome. So let's summarize what we have covered in this chapter. TypeScript functions are basically same as JavaScript. However, the use of TypeScript functions become easier and convenient with the type annotations. Adding the type annotation to the function parameters and the return values gives us a brief idea about the function at the first glance itself. We can even use the function types which are defined by the function parameters and the function return type. We can have the flexibility to use the optional parameter and default parameters, where we can call the functions with fewer parameters and they will still have valid values. Arrow functions in TypeScript help us define anonymous function with clean syntax. So this was all about using TypeScript's built-in types for variables and functions so far. Let us now dive deeper into TypeScript to learn to create our own custom types using interfaces and classes. Hi, this is Annapurna. In this new chapter, we will see how we can create our own custom types in TypeScript and take full advantage of the great type checking support of TypeScript. We will see the object-oriented side of TypeScript. Creating custom types in TypeScript is mostly about using interfaces and classes. We will first check out the difference between the two. This will help us to choose whether we need an interface or we need a class. When we create the classes, we will have multiple TypeScript source files. So along the way, we will also see how to configure a TypeScript project to support multiple TypeScript files. Let us start with having a look at the difference between the two. We use both interface and class to create custom types in TypeScript. However, there are significant differences between the two. Interfaces and classes both have properties. Properties includes the fields and the methods. However, for interface, we just define the signature of the property, meaning the property just has a name and the type annotation. For the methods, they are just the method signature. Whereas for classes, the properties have signatures as well as they are implemented. We can use the getter and setter methods for the properties in the class. The methods as well in the class properties have implementations. The interfaces cannot be instantiated. These are more like contracts in our application. If there is an object that implements the interface, the object is definitely going to have all the properties and methods defined in the interface. However, a class can be instantiated. Each instance of a class has all the properties and methods defined on the class. Now, taking a simple real-world analogy for interface and class, let's say I have a person. Now, I don't have much detail about this person, just that it has a name and age. So this person is much like an interface, which has created a contract to have a name and age, but the details are not in yet. However, if I go into the detail of a person, let's say he is a lawyer, this will carry more details about this person. He is definitely a person, but now his name and age is defined. With that, he has a specific profession and we also know about his workplace. Or he might be a sports person with all the details. So for such detailed representation, we use classes and instantiate objects for them. Hence, we use interface when we want to define the shape of the object with no details. We can use this shape in different parts of our application in different ways. If we need to define a list of properties which we can use to define a particular type of object, then we use interface. Let us now dive deeper into interfaces in TypeScript and use it in our demo. Interfaces are basically contracts that defines a structure and a syntax which an implementing class should follow. An interface can be implemented by a class. Such classes will be the implementing classes. Now this is the syntax to define an interface. To define an interface, the interface keyword is used, followed by the name of the interface. The body of the interface is surrounded by curly braces, and in the body we define the properties, the fields and the methods. So this was about the syntax of interface. Let us check out an interface in action. So here I am in the VS Code editor. In our demo app, I am continuing with our demo app which we had created in the previous chapter. I have only added a new file person.ts here in my app directory. I have simply created a simple basic interface here. I have added two properties to the interface, a string type name and a number type age. We don't need the let or var keyword to define the properties in the interface. Now any object that implements this interface will have to inherit these two properties. Now let's see a slightly more complex example. I have added another interface here, developer. This developer interface has two properties, domain and experience. I have used the extends keyword to specify that this interface will extend the person interface, which means the developer interface will inherit all the members of the person interface as well as have its own property. It is not explicitly listed here, but it is known that we have the name and age property as well in the developer interface. I can also add a method to this developer interface. Let's say develop. The method in the interface just have the signature and no implementation. Also notice that we don't need a function keyword while defining a method in the interface. The develop method takes one parameter, which is of string type, and then it returns void. So here we have just defined the shape of the object which will implement the developer interface. The object will have four properties: name, age, domain, and experience, and one method develop. Let us now see how we can use the structural type system of TypeScript. This uses the structure of the object as type. Let's see how. Now I'll paste a piece of code here. And this code has defined a player object. This player object has three properties: name, age, and score. Now looking at the person interface that we have here, it has two properties: name and age. And this object literal also has these two properties: name and age. And here the third property, score, is not on the person interface, but it implements all the property that the person interface has. So even if it is not explicitly mentioned here, this player object implements the person interface. It can be used anywhere where a person interface is expected. So I can declare a variable like this as well. Here, this variable another person is of person type, and I have assigned an object literal to it which implements the person interface, this player object. So this is basically the structural type system of TypeScript. As long as the structure matches, we can treat an object as that structural type. This is called duck typing in TypeScript. So now let us create some interfaces that we will use in our demo app. We will now use more than one file in our demo. For each interface and classes that we create, we will have a new file. This is actually a good practice to structure our project. To begin with, I'll just clear all the code in this person.ts file. But before moving forward to add interface in this file, we need to make few changes in our configuration to support multiple files. I'll temporarily stop using Webpack to compile the code. We will run the compiler from the terminal from now. So in the Webpack config file, I'll first change the entry point to main.js from the JS folder. And then I'll comment out everything else in the configuration file except for the section at the bottom that configures the dev web server. I'll use this dev server to serve the app to the browser. Next, in the index.html file, I'll have to update the reference to the JavaScript file to be main.js. Done. So that's all we need to set up to run the compiler from the terminal. Now let's begin with creating interfaces. And here is my person interface. I have defined one property, name. Notice here I have added question mark with the property name. This, like the function parameter, marks the property as optional. The objects which implement this person interface are now not required to implement this member. On hovering over it, the compiler also marks the type as string or undefined. If I remove this question mark, the tooltip now gives me the type of this property as only string. I'll keep this as a required property. Now the other thing in this interface is the function member format name. It takes no parameter and returns a string. This member is not optional, so the implementing object has to implement this function. Now I'll create another interface, a result interface. For that, I'll create a new file result.ts. This result interface will represent the result obtained for a game. This again is a basic interface. It has 3 properties and no methods. I want objects that implement this interface to be able to store the name of the player, the score they got in the game, and the number of problems they solved in the game. I'm using this simple example just for the demo, just to clear out the underlying concepts. I could have created a class with the same property, but since I don't have any methods to implement and I'll be using object literals to implement the interface, I don't really need the additional features offered by the classes. So here my result interface is ready and the person interface is ready. We will see how to implement the interfaces in classes, but now we will just use the object literals until we learn about classes in the next lesson. So let me first create an object literal for this result interface. I'll do it in this file itself. I'll create a new variable, say new result, and annotate its type to be of result interface. Now when I initialize this to an empty object literal, you see I get an error here. The compiler tells me the object is missing the following properties from type result: player name, score, and number of problems. Now you see, if I mark this as optional, I just need the score and number of problems and not the player name in the object literal. I'll remove this. I will add the properties to this result object, so let me add them. Player name Anna, score 5, and number of problems 4. We are good to go now. Coming back to the person interface, I'll define another object literal here which implements the person interface. I have declared a new variable called newPlayer and defined it to be of person type. I have implemented the 2 members of the person interface, the name and the format name function. The format name function will return a trimmed version of the name. I have hard-coded it here for now. So this is how the object literals can implement the interface. This is just for the demo to show you how it works. I have created the object literals in the interface file itself. However, this is not the correct place to have these implementations. Interface in TypeScript is a development time tool. This means the compiler uses interface for type checking during compilation, but do not compile the interface to anything in JavaScript. I'll show you how. Now when I open the terminal, Ctrl plus backtick and create a new terminal, I'll go to the app folder and compile this new interface file which I have created, tsc person.ts. Now I have this person.js file created here, and this code is just for the object literal which I had created here in my person.ts file. However, the code for this interface person is not mentioned anywhere in my JavaScript file. Thus we can say the interface is compiled but has no work in the runtime. So I'll delete this person.js file for now. It was just to show you how this works. So this was all about interfaces. We will use this in our demo application. However, we do not need this objects which we have created for our demo app. So I'll remove it from the interface files, from result, as well as from the person file. And now we are good to go. Let us now check out classes in TypeScript and take our demo app a step further. Let's understand classes with examples. So here in my demo, in the app directory, I have created another file, picture.ts, and added some code to it. We will learn about classes from this file. I'll close this sidebar because we don't need it now. So here I have defined a class named picture. The syntax to define a class is to use the class keyword followed by the class name. And this entire piece of code is the body of the class. I have defined 3 field properties for the class. art title, owner, and price. Here I have used price with the underscore. You will know why. The definition of the field property uses the same syntax as we had seen in the interface. However, we can use the accessor methods, the getter and setter methods to access and modify this property in the TypeScript class. Thus, they provide implementations which the interface don't. The class members can also have the SS modifiers. We can use this to control the accessibility of the class members. By default, all the class members are public. However, you can explicitly use the public keyword as well, like I have done here for the art title. So here are the SS specifiers: public, protected, and private. The protected members can only be accessed inside the class or any class that inherit from this class, whereas the private members cannot be accessed outside the class. So this was about the SS specifier. Next, I have been telling about the accessor methods. This is the getter and setter method which I am using to update the private members price. Price is my private member here. These are basically like any general functions except the get and set keyword that are used with the function. Here in the getter function, there is this get keyword in the function definition. The name of the function is the name of the property, price for me. The getter function should not take any parameter and return the value of the property underscore price here. Similarly, the setter method is defined with the set keyword with the name of the property as the function name. It takes one parameter. This parameter is the value to be assigned to the property. Here I am taking the parameter new price and storing it in the backing variable. This underscore price here is my backing variable which I am using for the private property. Now for a read-only property, we can just implement the getter and not the setter. For example, here, if I make this price property read-only, here you can see I get the error in my setter method. So with the read-only modifier, the field cannot be assigned a new value in the setter method. For now, I'll remove it. Now another thing to note here is the use of this keyword. To refer to a class member in a class, we need to use this keyword followed by a dot and the member name. Now, class methods are defined in the same way as general functions. One difference here is we don't use the function keyword in class method definition. So like any other function, this is the order picture. It takes one parameter, returns void, and I have just added a log statement here for the demo purpose. So now we are familiar with the class members in TypeScript. Let me briefly show you something about the private fields in the TypeScript classes. Let's see here, if I create a new instance of a picture class, say new picture. Now here, this private specifier restricts the access of the members at the design time. We cannot access it from outside the class. So if I try to access this price property from outside the class, I won't be able to. I don't get the property in the list of options here. Even if I do it explicitly, I get an error. But now if I try to access it using the bracket notation in the TypeScript itself, I will be able to do it. You see, I get the option for the private property, and now I can assign a value to it. So this is called soft private in TypeScript. A private property can be accessible using the bracket notation in TypeScript. This can be a drawback, but this is helpful at times like unit testing. Also, after compilation in the output.js code, it will be a plain class property without SS specifier. Hence, it can be accessed by any other piece of code. Now to create a private field which won't allow any of such access in TypeScript or in JavaScript compiled code, we can define the variable to be hard private. To define a hard private property, I just need to add a pound sign in front of the property declaration. Let's say new price which will be of number type. And now when I try to access the variable using any of these three ways, I'm not allowed to do it. Using the simple conventional method, or using the pound sign, or using the bracket notation. So this is a hard private declaration of TypeScript, and this keeps the property truly private. Now what type of private we need to define the variable to be depends on the use of the code and the JavaScript runtime support. So this was basically an overview of class. We can simply define a class using the class keyword followed by the name. The body of the class is enclosed within the curly braces. We can define the class property with the SS specifier. There are two types of private in TypeScript: soft private and hard private. We can also have the accessor methods in the class, the getter and setter methods, and then we define the methods of the class members like any other function but without the function keyword. We can also create new instances of the class. Let us now see how can we extend classes and implement interface. Now in previous lessons we had seen how an interface extends another interface. In the same way, classes can extend classes. I am in the same picture class from the previous lesson, but here I have made some update and cleaned up the code in my picture class. I have removed the SS specifiers and kept the simple rTitle and price properties, and here is our class method, orderPicture. I have removed the getter and setter methods. And next here I have created another class, class photograph, and this class extends picture class. So now this photograph class inherits the members of the picture class, the rTitle and the price, and the function orderPicture. Besides this, it also has its own properties, one the camera and then the settings. Now let me change this setting property to a function. Let's say change setting function. So my photograph class has a field property and a method change settings. So basically picture is my base class and photograph is my child class which extends the base class. Now if I create an instance of a photograph class, let's say new pic, the variable name of type class photograph will be equal to new photograph. Now when I create a new instance of the class like this, photograph followed by a pair of parentheses, this basically is the call to the class constructor. Now I will use this to set the values of the properties of the photograph class as well as its base class. Now this was extending classes. When it is an interface, we need to implement it. Let's say we define another interface here. Let's say artist. This has two properties, full name and age. So here if I want to implement this artist interface in the class photograph, I can just use the implement keyword and implement the interface. Now as soon as I implement this interface, I immediately get an error. It says missing property from type artist, full name and age. So we are required to provide an implementation for all the required properties of the interface here in this photograph class. So I'll add the implementation for full name and age. And the compiler is now happy. Now once this is done, we can use the accessor methods to work on these properties or do whatever you want to do with it. So this was it. A class can extend another class, whereas it will implement an interface. Let us now cover a couple of more topics related to class and then we will work on our demo app. In this lesson, we will learn about the static members and how they are different from the class members we have seen so far. By default, we can access a class member only after creating an instance of the class and assigning a value to it. And then we can access the members. However, static members are different. The static members can be accessed without creating an instance of the class. Let me show you how. Now let's say if I mark this art title of the picture class as static, I can do that by just adding static keyword before it. Now when this art title is static, I can access it directly without creating an instance. Just use the class name followed by the dot operator and then the member name. For example, here you can see when I have used this static member art title, I'm getting an error. It says use picture.artTitle instead. So here instead of this, I can directly use picture.artTitle. There will now be only a single instance of this member which exists on the class itself. This is also applicable for using the artTitle property even outside the class. If I use the class picture followed by dot, I get the option to use this property artTitle. So we call the static members using the class name instead of the new instance. The static members are generally helpful to create the helper or utility methods. These methods are defined in a class, but they do not depend on the data stored in the instances of the class. So this was another variety of the class member. Now let us have a look at the special type of function, the constructors in the class. In this lesson, let us check out constructors and how they are different from normal class member functions. The constructors are functions in the class, but however they are different from other class methods. The constructors are executed when an instance of a class is created. Hence, we can use it as a place to perform any setup or special initialization for the new instance of the class. Let us implement constructors in our demo here in the picture class. Now since I haven't used constructor here, it is clear that constructors are not essential and are optional. Let us add a constructor and see how it works. The name of the constructor function will always be constructor, followed by parenthesis. This parenthesis will contain parameters and then the body of the constructor. Here currently I haven't passed any parameter to my constructor function. I'll simply add a log statement here. So this, my friends, is a very simple example of constructor. To look at a little more complex implementation of constructor, let us look at a more complex class. Coming to our photograph class, let me add a constructor here for the photograph class. Here it takes one parameter, which is of string type, and the name is new camera. Now in the constructor body, this is calling the superclass constructor from the child class constructor. The superclass for my photograph class is the picture class, which is also called the base class. Now since this base class picture has a constructor, I also need to call the base class constructor from the child class. The string value which has come in the constructor, I have assigned it to the class member camera. So initializing the class member is one of the main purpose to use constructor. When I move a little further down, you can see I have got an error where I have created the instance of the photograph class. The error says that the constructor for the photograph expects one argument. Now since my constructor has one parameter here, I'll have to pass the value for this. So let's say I just add a default string here, say Sony. Now you can see the error is immediately gone. So this was about constructor. If I want to change the value of the camera property, I can simply do it by calling it from this object and assigning a new value to it, say Canon G7X. So even after a property is initialized in the constructor, I can reinitialize it. However, I want to speak about another property which I had shown in brief in the previous lesson, the read-only modifier. Now let's say I make this camera property as read-only. The read-only variables can be initialized when they are declared here itself or inside the constructor like we have done here. You can see I have got an error here. It says cannot reassign to camera because it is a read-only property. So this is another specifier which you can use with the property depending on its use. So this was all about constructors in classes. So far in this chapter, we have seen interfaces implementing interfaces. We have seen classes. We saw classes extending classes and implementing interfaces. We learnt about the SS specifiers in class members, the variables and the functions. We saw static class members and we also saw special class functions, the constructor and its uses. Now let us use all of this concept and take our demo app a step further towards completion. I'll remove this picture.ts file. We don't need this for our demo. We already have this person interface and here the result interface. Now I'll create a new file player.ts and create a player class there. I'll add the code for the player class. I'll use this class to represent a player in the game. This class implements the person interface. So here the class members name and format name comes from this person interface and the player class has high score property of its own. Now coming to the main file, I'll refactor some code here. I will move this getInputVal function to a new helper class. To do it, I'll create a new helper.ts file. Here I'll create the helper class. And then from the main.ts file, I'll cut this function and paste in my helper class. So now here the getInputVal is the class member. So I'll have to remove this function keyword from here and just set the alignment. I want to be able to use this function from anywhere in the app without creating the instance of this helper class. So this function will return me the value of the HTML input element. So I'll remove this else block and have it return just the input element's value. So with this change in the getInputVal function, when I go to the main.ts file, I have got an error here. I'll update this to call the static function using the helper class name. I'll also remove this undefined union type from player name variable. With this, I got another error here. It says type string union undefined is not assignable to type string. So when I go to this getInputVal function, I'll also have to change this return type of the function here to just return the string value. And now we are fine in the main.ts file. We have got multiple source files in our project and all are interdependent. We need to make changes in our code and configuration accordingly. We have changed the configuration in the webpack because we want to compile all the files by ourselves and our entry point is main.js in the JS folder. So now let us open the terminal and compile the files. So here in my terminal where my server is running, I have got an error. It says cannot find name helper. The issue here is that this helper class is defined in its own TypeScript file and compiled to its own JavaScript file. But the helper JavaScript file is not referenced anywhere in my HTML. When dealing with multiple files, I have the option to mention each of the JavaScript file in the script tag here. But this is not the correct way to do it in small projects like ours or in the large ones. Rather, I'll make some configuration changes now. In the tsconfig.json file, which is in our app directory, we have got this include option with this blob reference. This blob tells my compiler to compile all the TypeScript files in this directory and all the subdirectories. My compiler thus was able to recognize the code from the helper file in my main file. However, this code is not sent to the browser. What we will do now is comment this include option and add another option called Files. This Files option can hold an array of all the TypeScript files to compile. The starting point of my application is main.ts file, so I have just added the main.ts file here. In the main TypeScript file, since my compiler only compiles this file, in the start game function, I have got this error. This is because now my compiler does not recognize this helper file anymore. To fix this, I'll include the helper file in my main.ts file. To do that, we will use the TypeScript's /directive. At the very top of the file, just type ref and there is this built-in code snippet in Visual Studio Code. Just hit enter and you will get the entire line for it. This is a single line comment which we need to add at the top of the file to provide additional instructions to the compiler. These have multiple uses, but now we will just focus on adding the file reference here. So here we will reference the helper file. And now the error is gone. This basically means that the code in our main.js file depends on the helper.ts file. So our helper file will automatically be compiled whenever it compiles this main.ts file. At this point of time, we have no errors. In the terminal also, the compilation was successful without any error. I'll delete this JS folder now, and I'll run the compiler to compile the TypeScript file myself. In this new terminal, I'll clear this out first. I'm already in my app directory. Now I'll compile my main.ts file along with mentioning the out directory as JS. Just notice, here I have got my JS folder with the compiled helper and the main.js file. Notice that I had only asked my compiler to compile the main.ts file. However, my helper file was also compiled due to this reference here. The other TypeScript files, the person, player, and result.ts file are not compiled yet, since they are not mentioned anywhere. I think this is a better way to control which files are compiled, but it doesn't solve the problem of how to send all the correct code to the browser. Just the compilation issue has been resolved. Now I'll add another configuration option in my tsconfig file. It is called the outFile option. I'll add the outFile option in my compiler options. I have set the value of the outFile to a bundle.js file in my JS directory. Now what this option does is, it will take all the compiled files and put it in one single file and make sure that they are properly ordered. So now I'll have one output file bundle.js in my JS folder. Now I'll have to reference only this bundle.js file in my index.html file, and all my JavaScript code will be sent to the browser. So keeping this in mind, I'll change the reference in my index.html file as well. I'll make it bundle.js. Now we will see the effect in the terminal. I'll first remove this JS directory. And now coming to the new terminal, there is another change that we need to make. In the webpack.config.js file, I'll have to change this entry point from main.js to bundle.js. I need to restart the compiler, so hit Ctrl+C and stop this. I'll clear this out for now. I'll start the compiler, tsc. And my compilation has started with 0 error. Here I have got a JS directory with bundle.js file which has all the code which will be sent to the browser. Now when I go to the browser, hit refresh, I'll enter a name here, and now on hitting start game, it gives me the output, Anna, your score is -10. Notice that this input value is fetched from my helper.ts file, and the code which we have in our main.ts file is executed. So using a / directive technique, each code file can specify the other files that it depends upon. Let us move forward and add functionality to show numbers, display the game, and make it work. Now let us set up our scoreboard. For that, we will create a separate scoreboard.ts file where we will write the code for the scoreboard class. I'll add a file in my app directory, and now I'll paste the code for scoreboard file. I have used the result interface, hence referencing the result.ts file here using the / directive. I have then defined the scoreboard class, and in that I have a private class member result. This will implement my result interface in the scoreboard class. In this create result member function, I have updated the value of the result variable. Next, I have the update scoreboard function. I'll close this. Now in this update scoreboard function, I have created an output variable which stores the HTML to display on the screen. Here I have fetched the HTML element with ID player score and set its new HTML to this output variable. This displays the player name and score on the scoreboard. That's all for the scoreboard class for now. The next important class to add is the game class itself. This will represent the game that is played. To do that, I'll add another file game.ts and add the code for this file here. I'll close this sidebar, and here is my code for the game.ts file. I have added references to the other files that we need here, the helper file, result file, player, and the scoreboard file. And here I have added some basic functions that we need for the demo functionality. I've created a private scoreboard member in which I have initialized a new scoreboard instance, because if there is a game, there will be scoreboard. Next, I have the member player whose value I'm setting here in the constructor. Now there is another way in which I can initialize the class members in the constructor. I can change this constructor parameter to the member name, say player, add the SS specifier to it, public, and then remove this initialization here from the constructor body. With that, I'll also remove this player field here from the class. This declares a new class property, player, and initializes it with the value passed to the constructor. Next, I have these three functions: display number, display game, and calculate score. The display number function will be used to display the numbers on which the math game will be played. The display game function will display the HTML to represent the game board on the screen. Last, the calculate score function will fetch the answers that the player enters and check if it is correct. It will generate the result and display it on the scoreboard. I hope you're getting an idea of the code structure that we are going to follow. Let us write the code for each of this step by step. This display number function will be called when we hit the button show numbers in our app. So our first step will be to add the listener to the button, and we will do that in our main.ts file. I'll remove all the code from this main.ts file and start new. So this is the new look of my main.ts file. I have first referenced the player and the game file, and here I have created an instance of the game class to represent a new game. I have added the code for event handlers for the show number button and the start game button. Currently, the start game just has a log statement and calls the display game function. Coming back to the show number function, when the button is clicked, I have first added a console statement. Next here, a new instance of the player class is created, and here I have set the name of the player as the value provided by the user. If the player name input is empty, I'll just assign the string mathPlayer to it. After this, I am passing this player to the game instance that I have created here. This will go to the constructor of the game class, and after that, the display number function will be called. But before that, I want to show you the error that I am getting in the player.ts file. Now because I'm using this person interface here, I'll have to reference the file also. So I'll use the / directive and reference the person file. The error is now gone and I'm ready with the code in the main.ts file as well. Now it's time to write the code to display the numbers. I'll generate some random numbers between a given range of number and show it to the user. And for that, I'll go to my helper class and create a static function for that. Here I have got a static function getRandomNumber into which I have passed two number parameters, a max and a minimum number. To keep the game simple, I'll generate the random numbers between this given range. Moving on to the game.ts file, I'll add those numbers as the member of this game class. So here the two numbers will be randnum1 and randnum2. The first number will be between 10 to 5 and the second number will be between 5 to 0. I have used the read-only modifier here. I'll have to display these two numbers which are generated in my game page. So let's write the code for it. Here I have fetched the HTML element with ID game numbers and set its value to the string which shows the two numbers generated. Let us once test the code that we have written so far. Moving to the browser, refresh the page. On hitting show number, my numbers are 6 and 1. So far so good. We have got our show numbers button working and the display numbers function is working fine. Next we need to show the game board when the start game button is clicked. Time to work on the display game function. In our main.ts file, I already have called this function display game when the start game button is called. So now I'll just directly write the code in this function. But before that, I'll create a couple of more class members which I'll use in the function. The first is the operators array of string. I have hard-coded the mathematical operators here just for the purpose of this demo. Next is the problem count, which depends on the number of the elements in the operator array. Now, time for the code in the display game function. Yes, I know this is a long piece of code, but it is easy. Here I have defined a string called GameBoard. This will hold the HTML for the game. Here, this for loop is creating the HTML for the game. Next here, I have appended the calculate score button into the HTML. In the game element, I am fetching the element named mathGame from my HTML, and here I am setting the inner HTML as this game board which was generated here. And at the end of this display game function, I have added an event listener for the calculate score button which is dynamically generated. On clicking this button, this calculate score function will be called. So let us add the code for the calculate score button now itself. So here basically we will fetch the player's answer, check if it is correct, and then publish the result on the scoreboard. Here I have created a variable score and this answer variable as well. I'll put it as number type here. Now in this for loop, I am looping through each problem that we had in the game. Here the input answer of the player is fetched. Next here in this if block, if the user has entered the answer, I'm converting it to the number type, else continue. I'm checking here if the answer is correct. If it is correct, I'm increasing the score by 1. So this way, I'll loop through all the answers that the user has given. If there is no input by the user, it will just continue and go to the next problem. After this, I have this result variable. I'm setting the value to the object literal here. This values of result is from a particular game. Now my result object is ready. Once I have checked the answers and received the score, I have called the createResult function and the updateScore function. After all this is done, I'll just disable the calculate score button. Now let's go through this once. In the create result, the new result is created, and when the update scoreboard function is called, the output of the scoreboard is changed to my score. The calculate score function is ready as well. I have all the pieces of my demo ready. Let us jump to the browser and test our quick math game app. Hitting refresh, I'll enter the name, show numbers 6 and 5, start the game. And here is the game board generated for me. 6 plus 1 minus 1 into 1 and by 1. Now if you're coding while watching this course, awesome. If you're able to get this, very well done. And kudos to you. Go ahead. Else, if you haven't got this output yet, just pause the lesson and get done with it until you have no error. This will help you to follow along further in this course. Now assuming that you have reached this far, I'll write the answers for it. I hope now you get it why I kept the numbers to be simple. On hitting the calculate score button, this button is disabled and here I have my score. I got 4 out of 4. All my answers are correct. Let us test it otherwise. Show numbers 9 and 1, start game. Let's say 10, 8 and I'll leave these two blank. Now on calculating the score, I got 2 out of 4. Since I have not answered this two. Another use case, show number, start game, 7, 7, 7, 7. Calculate score, 2 out of 4 because these two answers of mine are incorrect. So this way all the use cases are working for us. We have a fully functional version of our game. Congratulations to you as well. However, this is not the end yet. We have a lot more to implement in this game. So basically in this chapter, we have covered a lot of topics, mostly interfaces and classes, but there are many more concepts inside those. We were able to create our own type using the interfaces and classes. We checked out a lot of examples of defining class members, the functions and the fields, and we used the SS specifiers. Besides learning all this, we have also implemented each of this concept in our demo application. We have also configured our project to use multiple source file and output the compiled code into one single file, the bundle.js file. In the next chapter, let us move on to TypeScript module and its implementations. It will be fun using it in our demo, so don't go yet. This chapter is about creating and consuming TypeScript modules. In this chapter, we will learn about TypeScript modules. We will see the features of the modules. We have a fully functional app without using modules already in the previous chapter. So why modules? I'll tell you why here. Now all the browsers do not support module. To work for this, we will also see some supporting technologies to use modules in TypeScript application. We will then use the modules in our app by importing and exporting them. We will wrap up the chapter with the explanation of how TypeScript resolves the location of the modules that we import. So let's start with the reason why we use modules. We have already created a working app in the previous chapter without using modules. So why now? Well, for a small project like ours, it will not make much of a difference. But when we work with large ones, modules are really helpful. We can use the modules to encapsulate the implement details and only expose the required API we want the other modules to consume. This allows us to refactor our code in the module independent of the modules that consume the API and vice versa. So we can refactor the code in module A independent of these modules, and we can modify these modules independent of module A. And this remains true as far as this API doesn't change. Now modules can be designed to implement a specific functionality. hence can be referred to as large building blocks in our app. This way, the modules become reusable. We can use it as needed in different parts of our app as well as let other apps use it as they want. The support for modules in JavaScript first came up with the ECMA 2015 version. Before that, developers used the popular non-native formats with browsers and Node applications. However, with TypeScript, we can write the modules using the built-in syntax and run it through the TypeScript compiler. For this code to be supported with older applications or runtime environment that do not support native modules yet, we will have to use some supporting technologies. We use the module compiler option to specify which JavaScript module format our compiler should output. TypeScript uses the ECMA 2015 module syntax, but using the module option, we can have the compiler output AMD, CommonJS, UMD, or system modules along with the ES 2015 format. Node natively loads the CommonJS modules, but if we are writing a browser app, we might have to use the required JS or system.js libraries to load modules. Another option is to use a module bundler like Webpack. This will prepare the modules to execute in a browser as a part of a build step. In our demo app, we will use Webpack. Now let us move on to the syntax required to use modules in TypeScript. Exporting and importing modules. The API exposed by a module is defined by the elements that are exported from the module. Modules can export any of the TypeScript constructs that we have used in this course. It may be functions, interfaces, classes, or even simple variables. Let us see a few syntaxes which we can use to export modules. Let's say there is this person interface. I can make it available to other modules just by exporting it. Add the export keyword in front of the interface. We can also export the functions in the same way. Just add the export keyword in front of the function. Same with the classes. However, I have a default keyword here. It will be available for import just like other modules, but making this default specifies that this is the default item which will be exported from the given module. Now, if I don't want the contents of a class to be exposed to other modules, I can just define it normally without the export keyword. The code in this module will be private to it. Now, export statements serve much the same purpose as exporting a declaration. It's just a different syntax. Now, here are the same three items I had exported in the previous slide. Instead of placing the export keyword in front of each declaration, I will export it using the export statement. I can just use this export statement once and then put a list of items I want to export separated by comma inside the curly braces. Now when I use this list of export, I cannot take advantage of the default export. However, I have another benefit here. I can define an alias for the exported item. The syntax is to use the name of the item to be exported followed by as keyword and then the alias I want to use. So now I'll use this getInputValue function as getUserInput. And this will be applicable in the modules that I import. However, it will be getInputVal in the module where it is defined. To use the functionality exported from a module, we need to import it in the consuming module. Let's see the ways how we can import modules. So here is a basic import that I have done. I'm importing the item participant from the person module. Here's the syntax. The import keyword followed by the item you want to import, then the from keyword, and then the module containing the item which we are importing. Here I have specified the path of the module. So this will be called as relative reference. Now because of this, TypeScript will look for a file named person with a valid TypeScript extension in the same directory as the current file. We will see more about the references, relative references, and non-relative references later in this chapter. Now, once this participant item is imported, I can use it like any other class, function, or interface. Here, I have just declared a new variable to have the participant type. This is one way you could import the default export from a module. The default export from the person module will be assigned the name participant in this module, regardless of what it was named in the person module. Now looking at some more examples of import. Here I'm importing two items. We don't need to import everything that a module exports. We can be specific with what we want as well. Here I'm using the person type to create a new variable human. I can also import items and alias them to new names as part of the import statement. Here I'm importing the person class and specifying that I'll refer to it as participant. I do that by using the as keyword followed by alias I want to give to it. The person module will be known as participant in my current module. And just like previous example, I can use it like any other classes with the alias participant which I have created. Now another example of importing a module is this. Here I'm importing an entire module. Instead of listing the specific items, I have used an asterisk and then the name I want to use to refer to it in the imported module. I can now access items in this module using the alias followed by a dot and then the name of the item. So these were the few syntaxes which we can follow to import and export modules. Let us now implement the modules in our demo application. Before we start using modules in our demo app, there are few configuration updates that we need to do. In the tsconfig.json file, in our app directory, I have added this outFile option. All the JavaScript will be output into a single file. This way, I had only referenced a single file in my HTML. But I want to use the module bundler that will deliver them to the browser. So I'm going to remove this option for now. I will add a module option to specify which module format I want the compiler to output. I'll use the common JS format. So now we are ready to convert the individual files to modules. We will remove this / directives and convert each file into modules. Let us start with result.ts. Here, this contains a single item result interface. So we can just add an export statement here in front of the interface definition. And now this is a module. My result module is ready. Next, person.ts file. It's again a simple interface, so I'll just add the export statement here. Next, let's go to the player.ts file. Here it has a / directive that references the person module. I'll remove this and use import statement here. The person module exports an interface named person. So I'll just add the interface name inside the curly braces after the import keyword. This will be followed by the relative reference to the person.ts file in the same directory as the current file. So we are now importing the person dependency here. And here I'll change the player declaration so that it is being exported. Coming to the scoreboard file, I have already got errors with the result interface here. So here I'll change this / directive reference with the import statement that imports the result interface. I also want to make sure that I export the scoreboard class, so I'll add an export statement here. Next, in the helper.ts file, we will do it differently here. It currently contains a class with two static methods, getInputVal and getRandomNumber. So I will use this class to demonstrate exporting multiple items from a module. I'll first remove this helper class. And I want to export both of these functions from the module. I'll add function keyword in front of both this function and remove this static keyword from here. Now we have two functions in our helper file. I'll use the export statement here at the end of the file. So here the export keyword with the items I want to export is inside a pair of the curly braces. I have exported the getInputVal function as getUserInput to the consumer of this module. And the second item to be exported is getRandomNumber. Now let us move on to game.ts file that has quite a few references to other modules. I'll just replace this with the import statements. Now this module uses both the functions getRandomNumber and getInputValue from the helper module. I have imported the entire module by putting an asterisk here after the import statement. I'll refer to the module as helpers. Next, I have imported the result and player exactly as they were declared in the respective modules. Last is the scoreboard class. Here I have used an alias score panel. Now when I want to use the scoreboard class in this module, I refer to it as score panel. After adding the imports, I'll export the game class. Now we need to make changes in the code in the game class. I'll change all the scoreboard references here to use score panel instead. And here helpers.getNumber, so it will be helpers. Moving further down in the calculate score method, I have to change the references to the getInputVal function to use getUserInput and use the module as helpers. And you can see that Visual Studio is giving me some code completion help. I'll use getUserInput. I'll do the same down here. Okay, that's all the changes I need to make in this file. The last file to update is the main.ts file. Here I have got so many errors. First, I'll remove the / directive at the top and replace them with import statements. I have imported the game and player class first. I use the getInputValue function from the helper module. Since I have aliased that function to getUserInput when I exported it, I'll refer to it as getUserInput when I import it here. I'll accordingly update the references to getInputValue function in this module. Okay, that's all the changes we need to make. I have now updated the app to use modules. However, I can't run it yet. I have to configure a module bundler. But before I do that, let's see how TypeScript resolves module. To understand how TypeScript resolves the location of the module we import, we need to understand the difference between the relative imports and non-relative imports. These are few examples of the relative imports. The relative imports direct the compiler to a specified location on the file system where it can find the module. The relative references begins with either a slash or a dot slash or a dot dot slash to direct the compiler to the location of the file. Here, the reference to the software module is preceded by a slash that tells the compiler that the file may be found on the root of the file system. You can leave off the file extension and the compiler will automatically look for files with valid TypeScript extensions. The compiler will look for the person module in the same directory as the current file. For this, it will go one directory up and then it will look for order modules inside the picture directory. Here are few examples of non-relative imports. These are almost same, but they don't include any references to a directory structure before the module name. These two lines import the Lodash and the jQuery modules, but they do not include any reference to the paths. We use non-relative references when referring to third-party modules, whereas we use relative references when referring to our own modules. Let us now see how TypeScript finds the files referred to with non-relative references. Module resolution strategies. TypeScript resolves the location of the module by first checking if they are relative or non-relative references. After that, it attempts to locate the module using the configured module resolution strategy. We can set the module resolution strategy using the module resolution compiler option. The two possible values you can pass to it are classic and node. The TypeScript documentation mentions that classic mode is available primarily for backward compatibility. However, it's important to have a general understanding of the difference between the two. The first thing to know is that the default value for the module resolution compiler option is dependent on what type of modules we have configured the compiler to emit. Classic mode is default resolution strategy if we are emitting AMD, UMD, System, or ECMA 2015 module. For common JS module, node is the default resolution strategy. The process of resolving module in classic mode is very simple. We will check it now in a couple of minutes. If the mode is node, it's the same way node attempts to resolve the modules. Though it is not complex, it is certainly different from what happens here in the classic mode. Classic mode is less configurable, whereas we can configure the node strategy using the package.json file if it is present. Let us now have a look at some examples of how each of these modules would attempt to resolve both relative and non-relative references. Resolving relative imports in classic mode is pretty straightforward. Let us suppose this is a file named player.ts located in the source quickmat directory. Here, I have imported the person module and used / to indicate that it is in the current directory. In this case, TypeScript will look for the person module in the person.ts file in the same directory. If the file is not found, it will look for the person.d.ts file in the same directory. It is a different standard TypeScript file extension which we can use with the type declaration file. This type declaration files provide type information for JavaScript libraries that we want to use in our TypeScript projects. We will talk more about it in the next chapter. So this way, TypeScript resolves relative imports in classic mode. The compiler looks for a file with one of these two extensions in the specified directory. Coming to the non-relative imports in the classic mode, this is a little more advanced. I have imported the same person module, but here I have not given any path reference and hence it is non-relative. The compiler will begin its search for the person module with the same two files, the files named after the module name with either a ts or a d.ts extension. This time, if it doesn't find the file, it will go one level up in the directory structure and search for the same two files. It will continue moving up the directory structure until it either finds one of the files or run out of the directories. Now let us look at using the node resolution strategy with relative references. I'm using the same example import statement. TypeScript will first look for the person module in the current directory with one of the three valid TypeScript file extension. The tsx files are the TypeScript equivalent of the JavaScript JSX files used with popular frameworks like React. If those files don't exist, then the compiler will check for a file named package.json in a directory named after the module. If that file exists and has a types property in it, that directs the compiler to the correct file. Then that file will be used. Otherwise, the compiler will look in a directory named after the module. In that directory, it will search for a file named index with one of the same three valid TypeScript file extensions. The last one here is the node strategy with non-relative imports. I'll again use the same sample import, but this time with a non-relative reference to the person module. The first place the compiler will search for this module is in a subdirectory of the current directory named node modules. In the node modules directory, it will look for the file with the module name and the three TypeScript file extensions that we have discussed. If not found, it will then look for a package.json file in a directory named after the module inside node modules. It will then look in a subdirectory of node modules named types for a file named after the module with a d.ts extension. Then in a subdirectory of node modules named after the module for a file named index with one of the valid TypeScript extensions. If the compiler still hasn't found the module at this point, it will follow the same process up one level in the directory structure. The same searches will be performed here as well, and then it will continue moving up the directory tree, doing the same thing until it finds the modules or runs out of the directories. Looks like a lot of work, but don't worry. You now at least have an idea of how TypeScript attempts to resolve the modules. This makes it easier to figure out what's wrong when there is an inevitable error which says it can't find something that you're looking for to import. We also have a compiler option which we can use to output all the locations the compiler is searching. This is very helpful in troubleshooting module not found errors. Let us check out this in action in our demo and get our demo up and working with modules. So here in our editor, we will now see some additional module resolution configuration options. We will also trace the location where the compiler searches for modules. In our editor, let us make some changes in the tsconfig.json file. We will start by adding a module resolution strategy config option. We already have common JS module here, so the default resolution strategy is Node. But however, I'll mention it explicitly here. Now we will see how non-relative references are resolved. Let us go to the player.ts file and change its reference to use a non-relative one. I'll remove this // from here, and this immediately gives me an error. It says it cannot find module person. As we saw in the slides, there are a lot of different locations TypeScript searches for modules based on the configuration of our app and how we reference our modules. It is tricky to understand why a module isn't being found. So to resolve this, we have a TypeScript compiler option called trace resolution. Let us turn this on in our config file. So in the tsconfig file, I'll add trace resolution compiler option here. Now our compiler will output information about how each module import is being resolved. I'll open the terminal. In the app directory, I'll explicitly stop the compiler and start it again. Here is the tracing report. I know this looks a lot to go through and understand, but it is not as complex as it looks. I'll go to the top of the report here and first see the modules that are resolved. You might not be able to see all the reports in your terminal. To do the setting, you can go to Code, Preference, Setting, and here search for scroll back. Then go to the terminal option and here change the maximum amount of line to 10,000. So once you do this, you'll be able to see all the reports in your terminal. Here the first line says that it is trying to resolve a relative reference to the game module from inside the main.ts file. Here it shows me the module resolution that I had chosen, which is Node.js. And then the next line indicates the location our compiler has searched for the module. This last line for the import shows that the file was found and it will be used as the resolution result. So this was the module which was resolved. Scrolling down a little, let us find the attempt to import my non-relative person reference inside the player.ts file. And here is the resolution for my person module. It says resolving module person from player.ts file. And then it checks the node modules folder and looks for this file with any valid TypeScript extension. When it is not found in the node modules, it moves one directory up and looks for the JavaScript file where it can find any type of my TypeScript files. So here is the search for the JavaScript files, and ultimately it says that the module named person was not resolved. Generally, the non-relative references are used for the third-party libraries, so it makes sense for TypeScript to search for it in the node modules folder. Now if I move this person.ts file to the node modules folder, let's say I move it here. When I hover over this person module, it says the module was found in the node modules directory. I'll move the file back to its original place. Now let's see some more compiler configuration options to configure more about the location of the module. Let me first create a new module folder inside the app folder. And now when I move this person to modules folder, it again says that the person module was not found. Let's see few more compiler options here. So in the tsconfig.json file, I'll add a base URL configuration option and set its value to the new modules folder which I have created. This option specifies the base directory which the compiler should use when attempting to resolve a non-relative module import. So now all the non-relative imports will now happen to be relative to this base URL. We can see the base URL option here, and it is set to the modules folder. In the trace information for the non-relative reference, we can see it is resolving the person modules in the player.ts file. The error here is gone, and here the module was found inside the modules directory. Scrolling down a little, it says person.ts file exists in this location and will be used as the resolution result. So the base URL compiler option is handy if we want to configure a different location for the compiler to search for modules. However, I don't want to use them in my demo app, so I'll just leave it commented out here for you to reference it. Now coming back to person.ts file, I'll move it to its original location and remove this modules directory. I'll also change the reference to the module here in the player.ts file, and it is now using the relative reference. So this was all about the module resolution strategy. The last step to get this going is to configure the webpack as the module bundler so that our app will be out and running again. So we will do that in the webpack config file. Here I'll uncomment all these webpack configuration options. This will help to do the bundling and generate the final JavaScript file to the browser. I'll change the entry point to main.ts file in the app directory. Here we have used the TS loader as a webpack plugin to compile our TypeScript code. Here in the resolve option, the compiler will look for modules and files with this file extensions, and after this, Webpack will bundle it into a single output file called bundle.js and send it to the browser. Webpack takes care of bundling all the modules in correct order and placing it in the bundle.js file. Now let us check out our index.html file to make sure we have referenced this bundle.js file in the script tag. Yes, it is bundle.js here, and we are all set. In the terminal, let us restart the compiler and start the web server with npm start. Control backtick. We'll stop the compiler. We'll stop the server and start everything again. Compiler has started, and now the web server. Move to the browser and refresh the page. I'll play a quick game, enter the name, show the numbers, start the game, and let's enter the answers here. 12, 6, 27, 3. Calculate score, and here is my score. Voila, we have got everything working, and our app is now using the TypeScript modules. Have you reached here yet? If not, you can just pause the video and try it out. In case of any trouble, feel free to use the comment box and start a discussion. So let us summarize what we have learned so far in this module. Modules makes it convenient to organize our code to group similar functionalities together and reuse them as well, thus giving a higher level of abstraction to our code. We can use the import and export statements to make our modules available for others to use and use other modules in our code. We can even provide aliases to the modules. We converted a fully functional TypeScript app to use modules in this chapter. We also converted the fully functional app from the previous chapter to use modules in this chapter. We checked out how TypeScript resolves the modules. Ultimately, we need to stick to the strategy which suits our project the most. Now let us move to the last chapter of this course and check out type declaration files. We can include almost any of the JavaScript libraries or framework in our app. So in the next chapter, we will see how we can use those libraries and enhance our coding in TypeScript. In this chapter, we will see how we can take advantage of the available JavaScript libraries in our own TypeScript app. We will see how we can write the codes faster. And we will do that using the type declaration files. In this chapter, we will see what are the type declaration files, where can we get them from, and how can we use them. Well, speaking about what are type declaration files, these are referred to as the type definition files or type libraries. These are the wrappers for the existing JavaScript libraries. We define the type declaration files with extension d.ts. The purpose of this type declaration files are to declare the types in our code for the variables, functions, objects, and other constructs in the libraries which we might want to use. This could include referencing the correct properties on an object or passing the expected numbers and types of parameter to a function, thus making sure that we use the libraries correctly. While working with the JavaScript libraries, when we compile our code with a type declaration file, we can find the error at the compile time itself. The declaration files, however, are not a replacement for the JavaScript libraries. Instead, they are just a development time tool to assist the compiler. Even if we use the type declaration files, we will have to install and use the JavaScript libraries in our application. We should check if we have a type declaration file available for it. But where are we supposed to look for this type declaration files? Type declaration files are mostly included in the JavaScript libraries that we use. But there are a very few libraries that might not have the declaration file. However, there is a huge Git repository of type declaration files created by the JavaScript and the TypeScript communities. And this GitHub repository is called DefinitelyTyped. They also provide updates for the file from time to time. But since these are maintained independent of the JavaScript libraries, this might be sometimes slightly out of sync. We can get the individual files from the GitHub repository directly, but DefinitelyTyped is also the source for several installation utilities that makes it easier to install the files that we need. We can install the files easily by using npm just like any other packages. They all exist inside the types organization and usually have a name that matches the library that they belong. The files are sourced from the DefinitelyTyped repository on the GitHub. Let us install a type declaration file and use it in our demo. I'll use npm to install the declaration files in our demo app. Let us move to the official TypeScript website and see how to search for the available files. Here they have provided a very nice search tool. Go to the tools link at the top of the page. Scroll down a bit and here is the link for the type search tool. From here, we can search for the package we want to use in our app. Let's say I want to use jQuery. Here I get several files that include jQuery in the description. I can use any of it which I want. But this is the exact match. However, I want to use Lodash in my demo app, so I'll search for it here. The declaration package for Lodash is the second item in this list. This way you can look for any library that you want. On clicking this, it takes me to the page for the package on the NPM website. In the Visual Studio Code, from the terminal, we will install the file. So I can just copy this installation statement and paste it in my terminal. But before this, I need to install Lodash in my project. So I'll move to terminal. So here my Lodash library was installed, and now I'll install the type declaration file for it. I have just pasted the command from the NPM website, hit enter. Now I have both the packages installed in my node modules folder and I'm ready to use them in my app. I'll use this library in my scoreboard.ts file where the score is displayed on the screen. I'll close the terminal, go to the scoreboard.ts, and the first thing I'll do is import the Lodash library in this module of mine. So here I have imported the entire module and aliased it as underscore. I have used the non-relative import to use this as the third-party library. Hence the compiler will look into the node modules directory directly. After this import, I'm ready to use this in my demo. I'll keep it simple for the demo. So in the update scoreboard method, here where it displays the player name in the result, I'll change this string to use the uppercase version of the player name by using the Lodash function. First, let me create a string for this uppercase character. Let's say let uppercase name, and when I type this underscore character followed by a dot, Visual Studio gives me a list of Lodash functions which are available. Now the compiler is getting all this information from the type declaration file. When I type upper, it filters the functions. I'll use this uppercase function and then the player name. This dot result dot player name. So here I have used my Lodash library. Take this and paste it here. And I'll just remove this. Now on hovering over this, I can see the type information about the function. It takes an optional string parameter and returns a string. I'll restart the compiler and I'll restart the web server. I'll play my math game for one last time here. Show number, start the game, put in the answers, calculate score, and here in my scoreboard I now get the player name in uppercase. So everything is working as expected. We have successfully used a third-party library in our demo application. This way, I can use any library that I want in my TypeScript project. The JavaScript ecosystem is very rich with thousands of libraries to do a lot of common tasks. So in this chapter, we saw how we can use these JavaScript libraries to make our coding very efficient and faster. The type declaration files also made this easy. Now instead of giving time to look up for the functions and the property names, we use the time to implement the features, which again becomes easy. Debugging also becomes easier due to strong type checking in TypeScript. So before using any JavaScript library in your TypeScript project, you should first go look for the type declaration file. So that was all about the type declaration files in TypeScript, and now we have reached the end of this course. I hope you enjoyed the course and noticed how TypeScript has made things easier as compared to JavaScript. You have now got all the skills you need to be productive with TypeScript, and you're ready to create your own TypeScript project. TypeScript is also popularly used with Angular, so you have got your back covered for Angular too. Thanks for watching the course and staying with us. If you like the course, give it a thumbs up. This motivates us to work and come up with rich contents like this for you. Subscribe to be a part of our Smartherd family. Keep smiling and happy coding.